This, folks, is an Adirondack chair, a classic piece of outdoor furniture, and incidentally, one of the most comfortable chairs ever designed. It's kind of like sitting in a great big hand. Oh, yes. It's a typical chair design in that the angle between the seat and the back is about 95 degrees. Actually, we increased this slightly when we made it. This is probably closer to 100 than it is to 95, so it's a little bit more like a recliner. But then you take that 95, 100 degrees and you tilt it back almost another 25 degrees, and it's really, really relaxing. Now, on the forum, several of you have discussed how to build outdoor furniture, and this is a perfect example. If you look over this chair, there are almost nothing but butt joints held together with screws. The only joinery that we have in this chair is right here, this little dado, which keeps the leg brace. Now, there is a good reason for that. Joinery creates pockets, crevices, where the water can run down in and stay. Sometimes you make a mortise and tenon joint in outdoor furniture. The water will run in, soak the tenon, and it'll just sit there and it'll rot out quicker, and the chair will fall apart sooner than if you had no joinery at all. You'll also notice that where we can, we space the pieces of wood apart. The back slats have quarter-inch spaces in between them, as do the seat slats. This is done so that the water can evaporate quickly. The quicker you get the water away, the less chance you're going to have that the bacteria will begin feasting on the wood. There's no glue here. Even though there are such things as outdoor glues, even they might fail in this situation. So everything is screwed together. The choice of woods is pretty important, because certain woods will deteriorate more quickly outside than will others. The best outdoor woods by a long shot are things like teak and mahogany. Both of these have oils in them that naturally repel the bacteria, but they also are extremely expensive. Along with those expensive woods, things like the cedars, western red cedar, aromatic cedar are good outdoor woods. Locust wood is a good outdoor wood. Surprisingly, so is poplar. Many people who build outdoor furniture professionally, especially on the East Coast, prefer Atlantic white cedar. That seems to be extremely durable outdoors, and not only that, it's durable in salt spray and salt mist. It doesn't seem to be affected. A lot of the woods that I mentioned before, Atlantic white cedar, will deteriorate quickly in a salt brine. There's also, of course, the treated woods. Most of these are treated with a cupric arsenate, and that's not exactly a good wood to get a splinter. If you happen to sit down and there's a loose piece of wood and you get a splinter on that, the splinter will fester quicker than other splinters will. I'd avoid treated lumber, although I understand some of the new treatments coming out are a little bit kinder to human beings than they have been in the past. So we'll see about that. The choice of hardware that you make when you're putting together an outdoor piece of furniture is every bit as important as your choice of wood. You'll see here we used brass screws, and the reason we did that is because brass does not rust. It tarnishes a little bit, but it doesn't really corrode in the presence of moisture. You might also use galvanized screws, stainless steel screws. The types of screws that they have that have been anodized and treated for decking are also good. If you are living on the coasts and you want to protect your outdoor furniture projects against the salt, You might want to go to a marine store and get some of the bronze screws that they have there. The bronze is impervious as anything is going to be to salt. The bronze is. Now, this particular chair is not meant, however, to be built out of wood. If you go and you download the plans from the blackboard, you'll see that we have two thicknesses of wood here, 3/4 and 1 1/4, instead of what is more common, which would be 3/4 and 1 1/2. And that's because we have adapted this project to be built with wood composites. These are the composites that are commonly available if you go into any home store. This is decking material. The decking pieces are 1 1/4 inches thick. Some of them have grooves on the back, some of them don't. We happen to work with one that did. You can buy trim for decking material, which is 3/4 inch thick, and this is it. This is strange stuff. It works very, very well, and of course, it is said to be completely impervious to weather. Although time will tell, it is slightly affected by both moisture and sunlight. We'll discuss that in a minute. It is not structural. If you're putting in a deck, you'll find that while you can buy the decking material, you cannot buy joists made out of this wood composite. They want you to use wood joists, something that is structurally sound. This is made from little chips of wood. If you go to the blackboard, you'll see that we have done several micrographs on this, and we've got a 60 power micrograph. This has been enlarged 60 times, and you'll see that there are little pieces of wood encased in plastic, polyethylene. They take old pallets. A lot of this is recycled materials. Old pallets, building materials, grind it up, get rid of the metal, and then melt down plastic shopping bags, basically, and put it back together again with the plastic encapsulating the wood chips. It does have a grain. If you look at it under the microscope, and here the 10 power micrographs will show you that along the length of the board, these wood particles are oriented pretty much all in the same direction. If you look at the end grain and you cut it, you're going to get the end of the particles. So there is some strength or some difference in strength along the grain, but it is also extremely flexible. Is it structural enough to build a chair? Apparently, yes, it is. This doesn't require the load-bearing capabilities of a deck. Time will tell us whether or not the slight amount of shrinking and swelling, and this does shrink and swell. These wood chips are encapsulated, but of course once you cut them, you've exposed them on the end, and the ends will react to moisture. Also, I would guess that where we have put the screws, moisture may get in under those. So we're going to. This is something of an experiment. Right now, it seems like a very good experiment that this will last a long time, much longer than wood. But there may be something here that we haven't allowed for. Basically, I built it because I wanted to see what this. Well, Drew and I built it actually, and we both wanted to see how this stuff worked, and we found out some interesting things, and I'll show you here. These are cut pieces. These were ripped on the table saw. This long piece, and it cuts extremely smooth. it really goes through the saw like a hot knife through butter. I have a jointer over here hooked up. It can be jointed. I've planed it. It can be routed. It can be dado cut. All right, you could probably shape it, although I haven't done that yet. But let me make a few joints, and you'll see. Cuts very well. It really does, and that's at wood speed. And if you take a look at the chips here, I want to come in close on the chips in my hand. You'll see that these are even curled up like wood chips. Yeah. No, you don't want those. You don't want those. But neither do you, Katie. But they work just like. Okay, all right, guys. There you go. That's the thing about border collies and labs. They've got to be right where you are, and they're interested in anything you're interested in. Whenever you have cutting to do, or you're cutting this wood with a saw, with planer blades, joiner knives, it be a drill bit. It behaves exactly as, or even a little better than, wood. However, when you come over here, this is a sanding belt that Drew and I have absolutely ruined trying to sand this stuff. It just gets embedded. It does sand, as you can see. I mean, there is a rounded corner on this, but it becomes quickly embedded in the sandpaper, and you can, as you know, you can take one of these rubber abrasive cleaners, and if this were wood, I could clean this up in a second. See that? It doesn't even touch whatever has become impacted there on the grit. It's almost like it's become welded to it, as you would expect with the polyethylene. Probably the sanding heats up the surface of the polyethylene, and it sort of glues itself right down to the surface. And that's another thing. Bringing that up, let me get the sander and the jointer out of the way here, and we have I have glued up some pieces of this wood composite, and we're going to perform an experiment right here to see if this stuff can be glued. Drew marked these as he glued them up. This is construction adhesive, like liquid nails. This is epoxy. We've got super glue, and then just ordinary wood glue. Now what I'm going to do is I'm going to clamp these things one at a time to the workbench. Let me move this out of the way a little bit. And then I've got a board here that I have marked in 6-inch increments. And I'm going to clamp this board to the piece that's been glued to the piece that I've clamped to the workbench. Now, what we've got here is, if you know your physics, I can take a weight and put it on these marks, and I will be getting an increasing amount of leverage as I go down to the end. we're putting a racking force on this glue joint. All of these glue joints are exactly 3 inches by 3 inches. So we're going to see here when these start to fail. I have 2 5-pound weights, and if I need something more, I've got a 20-pound weight right here. So let's start with 10 pounds here at the 6-inch mark. This is wood glue. That seems to hold. 10 at the 12-pound. That's holding also. Moving it out little by little. 18, 24, 30. There we go. 10 pounds at 30 inches, and we lost the joint. And we can expect the joint, and you can see that it was the glue and not the wood composite that failed. In fact, this is interesting, that the glue isn't even, this glue joint is at least 2 days old, and it isn't even completely cured. Apparently it cured around the edges and sealed off the rest of the glue, and kept that glue, some of this, from drying at all. All right, let's go from there. Let's go to super glue and see what happens. Same setup. Now, I would expect that the glues which require forming an interface, that is actually soaking into the wood, would do poorly. So that doesn't surprise me that the wood glue, it was Titebond, by the way, in case you're wondering, would actually be fairly. Now this is interesting. Look at this. This is gonna. Seems like it wants to break. This is we're at 36 inches now with the super glue. 42 inches, and that's gonna pop it. Okay. Super glue was a little stronger than the wood glue, and once again we lost the glue joint, but not the board. It wasn't the board that broke. So let's go on to the epoxy. This is just a standard 2-part epoxy like you can buy in any hardware store. I believe this was the slow cure, because that's what we normally get. All right, 6 inches. 12, 18, 24, 30, 36. Now that's amazing, isn't it? The epoxy didn't even do as well as the super glue. And again, we lost this joint at the glue itself. Again, no composite has been cracked out. Not only that, this epoxy is not completely cured in the middle here. There seems to be some. In fact, it's the plastic is sort of soft here, there seems to be have been some sort of chemical reaction with the polyethylene that prevented it from curing and made the plastic gooey. Okay. Last, let's go. This is a construction adhesive. In fact, this is liquid nails. And once again, this is done precisely the same way that we did all the others. These every joint is not only the same size, we let it cure exactly the same amount of time under pressure, clamping pressure. Okay? 6 inches. Whoa! 12 inches. Huh. There you go. I think what this proves pretty much is that this stuff cannot be glued. The best we had was what? The super glue out there at about 42 inches. But even that is not strong enough to hold together furniture. So let me show you how we have just a couple of joints left to do on this chair, and let me show you how we did them. Go back here to this gorgeous tool chest and get out a few brass screws, a stick of beeswax, and this is a nice little tool. If you haven't used one of these when putting together furniture and projects that require screws, this is absolutely great. Several different companies make these, but basically this is a countersink for your screw. You want to adjust it to the precise length of the screw for this particular material. You snap this forward and you can turn it around, and there is the Phillips head number 2 that you need to drive the screw. This is made for a number 8. I've seen these for 6s and 10s as well. And let me chuck this in this drill. One of the things that we did find about this stuff is that this takes a good deal of energy. It went through the batteries on our quarter cable drills pretty quickly. Finally resorted to an ordinary plug-in drill just to okay, why did we blow that circuit? I don't think so. Technical difficulties, guys. Hang on a minute. There we go. Apparently this doesn't like to work when it's next to the floor. Okay. Let's hope we can get enough juice out of this to do one screw. Each one of these screws has to be countersunk. If not, the soft brass you'll just tear out the head. Also, the material, this composite wood, will come apart. So I'm going to drill and countersink a hole for the screw. Switch to the driver, and then, and this is important, wax the screws. we found that this really eased the insertion of the screws, especially the long ones. Now, when you drive this, you just want to snug the screw up. You do not want to really crank down on this. If you crank down on this, the screw will act as a wedge, and this stuff does split out pretty easily. You just want to snug it up, and that'll be the end of it. Let's see if it's going to. Well, it might last for one more. You've also, when you're drilling, you've also got to retract the drill fairly often and clear the bit. The wood chips from this do not come out from the edge of the drill as easily as the chips from ordinary wood. So. That's it. That's all there is. That's all there is to it. Neat stuff to work with. I'm going to venture a guess that this chair is going to last a long time. We're going to find a place to sit this outside and test it, and we'll come back to this in a few years and let you know how it's going.